Hello, my name is Arthur Lewis Nunez. I work as an acoustic engineer at a company called Max Fordham. We're a firm of engineers who work with architects to design new buildings. Acoustic engineering is about designing buildings so that sound is controlled in the right way. So in many buildings it's important that traffic on the outside may be blocked out. It may also be important that speech can be heard clearly, so it's not too quiet or not too echoey like you hear in some large train stations. So while architects are mainly concerned with the way a building looks, acoustic engineers are more concerned with the way that things sound in buildings. One of the projects I've worked on recently was the Wessex Auditorium at Brentwood School, which is where we are now. The school wanted a new hall with fantastic sound they could use for plays, assemblies and for musical performances. In a very large space like a hall, there can be a lot of echo that makes it difficult to understand what someone's saying. In acoustics, this effect is known as reverberation. However, reverberation is needed to make music sound better, as it allows the sounds to mix and spread evenly throughout the space. The school wanted us to overcome this challenge and design a room that would sound equally good for music, plays and assemblies. This meant we had to find a way that the school could adjust the acoustic properties of the space, depending on what it was being used for. The way a room responds to sound is known as acoustics. The acoustics of a room depend on its size, its shape and the materials it's made from. Some materials reflect sound, some materials absorb sound, while other materials let sound pass straight through. By using different materials on the floor, the ceiling and the walls of a room, we can control its acoustic properties. Hard surfaces like concrete and brick reflect sound, causing an echo. Soft surfaces like curtains and carpet absorb sound, so there is no echo. Therefore, rooms with lots of hard surfaces can sound very echoey or reverberant. For this hall, we decided to use panels on the walls. The panels have foam on one side and timber on the other. They're on hinges like a door, so that either of the two sides can be made to face into the room. If the hall's being used for a play or an assembly, the panels are turned so that the foam side's facing into the room. Echoes are reduced and voices can be heard more clearly. If the hall's being used for music, the panels are turned so the wooden side faces into the room. Sound is reflected and music sounds better. We use computer simulations and calculations to predict where a building will sound before it's been built. Here you can see a computer model of the school hall. This shows in slow motion how sound spreads from the stage and bounces off the various surfaces before arriving at the audience. We run simulations to see how different sounds will be heard in different parts of the space. It's important to make sure that everyone gets a good experience of the sound. I've always been really into music and sound equipment. I studied physics at A-level and then at university. Acoustic engineering seemed like a great way to combine his interests, so I studied a year-long master's course in acoustics. Then I got a job as an acoustic engineer, which is what I still do at Max Fordham's. Knowledge of physics and sound waves is essential to what I do, as really acoustics is a branch of physics. Math is also very important, and I use it every day to do all the calculations that are needed to predict how things will sound. Acoustic engineers also need to be good at writing and good at explaining difficult things to people. We're often brought in to sort out bad acoustics in buildings that have already been built. This needs good problem-solving skills, as we often only have small pieces of information about the problem we're trying to solve. It can be like detective work, piecing together all of the pieces of information to work out what the problem is and what the best solution is. I enjoy being an acoustic engineer because it involves thinking about the sounds that are all around us day and night. It affects everything we do, even though we can't see it. In that way, acoustic engineering can make a real difference to people's lives.